Sweet. Have no idea if the sound is working. Sorry about this. I'm gonna check it. Testing, testing. Wait. Okay, that is working. Sorry, as always, I don't know what I'm doing. So, welcome to Programming Rainbow. I'm just going to be kind of messing around. I don't have any planned stuff. Maybe I'll talk about some stuff and do some coding and show off some stuff I've been working on. But yeah. So I streamed the other day for about 3 hours, and YouTube got about 20 minutes of it. But realistically, it was me babbling a lot and showing off a little bit of my projects, but the video quality wasn't very good. I've been struggling with why the FPS in the videos aren't very good. And I'm streaming at either 30 or 60 frames a second, but yet the video will be very choppy. And let me see if I can show you what I mean here. Let's see here. So I'll show you the stream I did the other day, just part of it. And be this guy right here, maybe. Yeah. And let's see if we can just play it. And I'll try to get to a part where I'm playing some video, something interesting.
But this might be from Bash as the client. Does this 1 million during the same how client from one deck to collection need to wait for
it's looking for a bit. That's supposed to show some movement that's happening fast, but actually isn't working at all. Or isn't working correctly.
I could have done it, checked it.
I was explaining IPC, or at least what I've learned about it.
I don't want to say, oh, the zero index, pretty much only doing with the snowflakes.
So this video right here, if we're looking at this, on my screen this was very smooth, but in the video that's captured, it almost looks like it's getting really low frame rate, but it's actually stuttering. And there's nothing wrong with my computer here. There's nothing wrong with anything. What I found is that since I'm grabbing two different audio sources and I'm processing one more than the other, FFmpeg is trying its best to sync
that part of the game is not
after the toolchain of the audio with the video that is capturing in real time. And there doesn't seem to be, I mean, somebody can correct me if I'm wrong, but there doesn't seem to be any way at all to buffer one so that they're happy with each other. So what happens is no matter what kind of buffer values you put, it's still trying to grab it in real time, and the timestamps don't match up. So basically it causes the video to look like it's massively stuttering. Let me turn this off. So hopefully if I were to show something running right now, see here, I can back to here. Let's show this running and hopefully it'll be smooth. This should be smooth. So I am trying to record this at 60 frames a second. So let's say it's as smooth as 30 because it might not be hitting, let's see what I'm actually running this at. This is running at 180 FPS, but my screen refresh rate is 120. And I'm recording at 60, so, it's 60 probably or less, so, depending on how it hits each frame. But yesterday, this would have been really bad, and all my videos before this. So my solution to this, and this is my solution, I saw a lot of other mentions over the years of people having this exact same problem with nobody ever having a solution to this problem. And nobody that I could find who ever asked what's going on with the stuttering. And they were specifically talking about when they're doing a X11 grab or I think even a KMS, the KMS version, that once they connect a microphone, suddenly it gets laggy. And what it is it's this mismatch of the time. So nobody has ever answered anybody on this. And I just, for the last, couple days, have been trying to figure out and trying everything, just, like throwing spaghetti at the wall, just seeing what would stick. And I'm asking AI all kinds of questions, just getting nowhere really fast. And so I kind of figured, if this is not actually buffering and this is a thing, but by turning off my microphone, the video would be fine. Or by enabling my microphone, but with no filter chain on it, or just one audio source and not the second one, I could get it with async to lock back in again, but nothing I could do putting any effects on it or anything, no matter what. Even if I gave it several seconds, if I gave it there's all kinds of other things you can do, like you can give it different threads and everything else. None of that worked whatsoever. So assuming that I just could not, there was no way to actually buffer it. What I did was decide, is it possible to just unlock the two, to just do my audio pipeline and then stream it back to myself again? So the craziest thing is it worked. Well, I think it worked. I hope it's working right now. So this is running. I'm running 2 instances of FFmpeg, and let me show you. So this is kind of this is my Go local that I was testing locally, and this is my Go live. So I'm sending it off to Twitch and to YouTube and saving a local version of the file. But what I'm doing here is I'm running 2 instances of FFmpeg, and I have all variables all in place for all this stuff. So let's go look at what these are doing. But basically, I'm grabbing 2 different inputs of audio. I'm applying some complex filter chain to it. I'm telling it it's 2 channels. I'm telling the codec. I'm mapping the output of the final bit of my filter chain to the output, and I'm sending it. And where I'm sending it is actually just to myself over UDP. So let me kind of show you. This is not a very good explanation, but where is it? So a lot of those, this is video stuff right here. None of that matters to what I'm talking about. One thing I'm doing, because the last time I streamed, before I moved, was somebody was saying that there was a problem with the sound from the left and the right. So I'm trying to use one of the called AI, but it's not modern AI. It's like some kind of simple audio filtering thing, but it was affecting the 2 channels differently. So what I did is, since my microphone is mono anyway, but is kicking out stereo, I just ran my audio filter chain as mono and then set it back to stereo at the end. So both sides, one side won't be being affected slightly different than the other. So what I'm doing is I'm setting it to my audio to mono first, because again, even though it is stereo, they're both the exact same. Later on in the toolchain, I set it to stereo. These are just variables holding it. Here's my high pass and low pass, again, just holding it as a variable. My denoiser, just hold on a second. So yeah, these are all kinds of things I had before. This denoiser kind of listens to the beginning of the audio for like 2 seconds, and it decides what kind of noise the mic is making, like internal hissing sound or anything like that. And I set the floor to around -50 dB, and I push it down 12. This is kind of hopefully getting clicks and S's, but I don't know how well any of this stuff works. And then this is that kind of not sure what it's called. It's like a little neural net thing to deal with the audio. And my compressor, I'm have no idea if I'm doing this compressor right. This is a compressor expander, but this is what I have. I'm not using this audio thing. I'm putting a limiter at the end. And I'm using this audio, this resync, because what I'm doing in this chain is on my microphone, I'm grabbing the mic. That's the first thing, the first input up here. My audio input right here is the mic that you saw in the ffmpeg command. So that would be this 0A. And I'm applying the mono to it. I'm doing the high pass, low pass. I'm doing the denoise, the sound processing to try to get non-vocal sounds out of there, the click, EQing it, de-essing it, compressing it, put the limiter on it, setting it back to stereo, and then applying the async to it. So it's synchronized, because I'm going to have two different audio. So I'm also capturing just the monitor audio of my laptop, and then I'm going to mix the two together. So I want my microphone to be twice as loud as the monitor audio. So sometimes there's sound in games or anything like that. So I'm putting it the monitor audio at half, which is 3 decibels down, and the mic at full volume. And this is basically me mixing the two together. And that is what you see in the FFmpeg for the filter complex, which is all of this put together. And then here's my 2 channels and everything else. Now here's what I'm outputting this now to UDP 12700. Sorry, I'm outputting this to 127.0.0.1 and 1.2.3.4. This is just a thing that the AI was like, why don't you try this? And I was like, yeah, because I was asking, can I just decouple it? Can I just stream it to, like, I was thinking, so I was asking it about decoupling it, and I was thinking about doing it to a pipe. And I initially tried a pipe. The pipe doesn't work because the pipe is like first in, first out or whatever. So even though I might start the thing, like if I start it 2 seconds advanced, it would fix the problem, but my audio would be 2 seconds off. If I were to change the timestamps with the, I forgot what the command is to change the timestamps to push it forward 2 seconds, I would actually get back to the same problem. It would start chopping the video again, because basically it's trying to get audio that's not ready yet. It's slightly off, slightly not ready, but no matter any kind of synchronization or buffering, never fixes that. So the pipe didn't work unless the pipe was going to be off. So this one, I'm just like literally whatever my audio process is, I'm streaming UDP, and then I'm going to capture it back to the second FFmpeg command that's capturing the screen. It doesn't care about any timestamps in the audio. So it still seems like it's synchronous, but it could be like, a couple milliseconds off or something, but it doesn't matter. It doesn't care. The final output of the audio that has been fixed now, hopefully, can be captured into the whole video, and this is all just me holding it in variables. But this right here, so I'm getting the microphone, the system, I'm mixing them all together. I'm doing channels, I'm doing codec. This is the final output of this filter complex. And then I am outputting it to that UDP. So in this second one here, this is where I'm doing the video. So this is all my video settings. It's basically I'm telling it I want it to be 1080p, 60 frames a second, things like that. The source is let's see what else is in there. I'm using VAAPI with the AMD GPU and stuff like that. So all that stuff's in there. The source is the X11 grab. And then I'm doing the audio. I'm grabbing that audio now back from that UDP socket. So I was putting it out to that address here. This is me just grabbing it back from that address again now. But they're desynchronized now, so they don't matter if they don't match up. And then I'm applying my video filters, which it's not really anything. It's just uploading it to the GPU. and the video codec, video compression, which I'm trying to use constant quality. So hopefully it's compressing down if I'm looking at a static image, but even if I'm looking at static or dynamic, the image quality should be the same, but the bit rate is going to increase dramatically if it's like a moving image because it's trying to keep the same quality. But I'm trying that. And these are the color settings. I have to re-encode the audio or I get an error. So like I was trying to just copy the audio over, but that wasn't seeming to work. So instead of copying the audio, I'm re-encoding it as AAC, which is what I'm doing up here again. So that's kind of annoying, and then I'm just mapping the outputs of those two. And this is the local one. This is exactly the same as the live one, but the live one, I'm using this, what do you call it? Mux, mutex, multiplex. I don't know, multiplex, muxer, whatever it's called, to split the stream out to send it to Twitch, to YouTube, and to keep a local copy of it as well. So this is kind of, I feel like it's a hack, but I cannot find anybody who has a solution. So this does work. Hold on. Sorry, my kids just came home. Yeah, so hopefully this is working better than it was last time. You know, and I'm not a professional audio engineer or anything, so like the way I'm doing the microphone and the compressing and the whole chain is probably not great. But if anybody knows how to do it better, they can let me know. That would be great. But yeah, so hopefully this is giving higher performance. Yeah. So that's kind of what I was doing with FFmpeg. Also, the reason why I stopped streaming is because we moved to Aberdeen. So if there is anybody in Aberdeen that likes programming, coding, or retro games, things like that, general nerdy stuff, yeah, let me know. I tried to create a page like this. You'll see this thing, so it's like Aberdeen Nerds or something like that on Facebook, but I don't really use Facebook very much, so I'm not sure how far that will go, but maybe if there's some other people that, jump on board. So yeah, in Aberdeen. So what I was talking about in the last video was this. I was trying to make, basically, I don't know what to call this, but it's like a bridge. It's like a Bash SDL3 bridge, because it's not it's not technically, how do you call it? It's not a binding, because that would mean that Bash is controlling the memory. What I've done here is I've made a server. I've made a C server that is SDL serving up SDL, and Bash is communicating with it through inter-process communication. And I've tried different methods out. So that's what I was talking about in the last video that I was streaming. I don't know how far into that video it got and how much it broke off, but I can kind of just show some of the stuff that I was doing. See if anybody is actually watching. Is this thing still working? Hopefully it's still working. Great. So let's go back to the Bash stuff. So I have a couple of things, that little snowman thing. Hopefully it'll work better. Let's try it out here. This is not finished at all, just a work in progress. So that's not right. Oh, .sh. Okay, so this is just basically kind of messing around. When I move the snowman, this text is going to turn into numbers of probably where the X location of the snowman is. There is also collision detection happening on all these flakes. This is being run from Bash. This is all programmed in Bash, but it's speaking to a C server. So I'll show that in a second here. It looks like actually collision's not happening right now. I'm not sure why, but anyway. Now the collision's happening. So I don't know why it wasn't happening in the beginning before I moved, but it was a work in progress, so there could be all kinds of bugs with this. But this is just me seeing if I could get things to move around. I can get the collision. I'm getting input from the left and right. I think, no. Yeah, I have left and right arrows right now. And I push spacebar to restart it again. Yeah, I think it's my X, my left side of the snowman. But the yellow flakes reset up above the screen, and the yellow flake ends the game. Okay, and I do have a title set up here. I do have this. All this is being done in Bash, so let me show you real quick. So this is what we were just looking at. This is just literally the commands. I was trying to figure out what commands I had implemented yet, so this is nothing. It's just, again, this is a work in progress because I'm working on two things basically: how to talk from Bash to C, and how to create this C server that's can do that. So what we have here is some of these things are completely in Bash, and some things are happening in C. So what's happening in C is all the drawing and moving of things are happening in C. The actual SDL stuff is happening in C, but Bash is telling C what to do. So the only thing that is different that's happening in Bash here is you can send a message to C, and you can receive back an answer or an array. Okay, so all of these other things we're looking at here are just straight up Bash. So this is the command right here that runs the whole thing, and this is a Bash function, and it has one argument, and this argument is the thing that's going to be sent to C. So this set SDL start, and I'm going to probably change this SDL here, but anyway, this is telling C, hey, C server, start up SDL. I need SDL to be running. And these right here are just straight up Bash, have nothing to do with SDL. I mean, I'm using them, but the SDL server doesn't care anything about these at all, or these. This is just an associated array that I'm just kind of setting up myself. It has nothing to do with the C server. Again, none of this. This one right here, I'm setting a title. If I don't set a title, it'll have a default one. Let's just see what it is real quick. I just commented it out so that I can see what it is, and it just says Bash SDL. So it'll say that until you set it to something. So this is why we set it. I say set SDL title, and then whatever the rest of the string is going to be the title. Set SDL icon, and then load an image. Let's find out what happens if we try to load the wrong image. And this is the image for the icon at the top left of the corner of the screen. And this should fail out, but this is a work in progress, so maybe it does, maybe it doesn't. And it did fail out, and it gives a helpful message saying error loading icon surface, could not open, no such file exists, and then it shuts down. And it shuts down the C server and the Bash script. So ideally, when something happens and it shuts down, both sides shut down because you can't move forward. So if the server shuts down, the Bash script, if it keeps trying to call stuff, it wouldn't be right. And let's see what happens if we just don't set that. So we have this, it's like the X window icon. That's probably the default. So that's what would be there. Okay, so PNG. Now we can set the window height. This is kind of silly right here that I'm doing because I'm actually setting it to, well, maybe I changed it. No, in this one I'm setting it to 800 by 600, but realistically, if I leave this out, it by default is going to set it. So we don't need to set any of these. There's the default for all of them, which is no icon 800 by 600, and it right now just says Bash SDL, but I might change it to something else. So if we set this, it's still the same size because that's the default one that I put, but you can basically override it. Now this first one is the first time we're loading an image. So two things need to happen here. I need to load an image, but I need to get back something like a handle in Bash to be able to reference that image later. So I'm calling that an ID, which is basically just a number. So what's going to happen here is, I say new image, and then this is the actual file of the image I want to upload. And if we spell it wrong or it's not an image, we have already seen that it fails out. But if it's successful, what happens is on the C server, it creates this image and then it puts it into an array, and it has an index to that array, and it hands you back the index to that array. Okay, so you don't need to worry about memory management. That's not, we're in Bash here. We don't need to do that. The C server does that, but it gives you back an ID. So, and for speed, I don't want to do anything like this. Now, I'm not a Bash expert at all, like I'm really not. So there's probably better ways to do this, but because of speed, because I want to make Bash run as fast as possible, I'm trying to not use any subshells. So I don't want to do anything that's like this, like let's say back image is like equals something like this, you know what I mean? Where like the answer to this gets put in here. This is a subshell. This is slow. So what I've done instead to be faster, and I would have to echo it from the function. I'm just going to show you where the function is defined. So this is the pipe one. So this command function is not here. That's the old one. Sorry. So this function is defined right here. And this is the sending something. And sometimes something needs to come back. If I have a get or a new command or an array, something needs to come back. If it's get or new, I'm receiving back a single answer. So this is me receiving the single answer. This is not a subshell or anything like that. So it is fast, but it's also blocking. So an answer has to come. If an answer doesn't come, it's going to sit here waiting for it. So my C server knows that an answer has to come back. So if it's a get or a new, my C server is sending an answer back, and this function is waiting for the answer. So that has to come back. Also, if it's array, ARR, I want to receive an array back. So what I do is, this is like a global variable, either reply or array, and I'm populating that global variable. So when you see here in here, I'm sending this command, and it says, okay, I'm loading this image. The C server loads the image. It sends me back an ID for that image so I can reference it later. And that ID is being held in reply. And reply is just a global variable. And so every time any one of these things, reply is going to be populated. So I'm just now taking what's in reply and setting it to back image, my background image. So this is just holding the ID of the image. And I can tell you, since this is the very first image I loaded, this is going to be 0. This ID number is going to be 0 because it's an array number. It's just going to give you a number. Hold on. Sorry about that. So yeah, so that happens every time anything needs to come back. It comes back like that. It comes back through this reply because I want speed, and I'm going to show you why I want speed in a minute. And after this, it's all going to make sense. But there may be better ways to do this too. If you're an expert in Bash, go ahead, comment on the video. Let me know what I'm doing wrong so I can improve it, because I always want to make it better if possible. You know, but I'm doing so. At the current moment, what you're looking at is kind of my very early version, where I am doing the SDL thing, where I'm loading an image and having a rectangle for it. I'm going to leave that in, but I'm also going to make like a sprite. Basically, you just say load an image, and there's an image. You get an ID back to a sprite, and that sprite is an image and a rect together to make it simpler for people. But right now I'm doing it separate, but you will see it later on with the text. The text right now is all encompassing. It's a text object that I've kind of created. that you just instance a text, and then you can change the size, the color, the font, what the text is. It doesn't matter. You get an ID to a text object thing, and it knows its own rectangle. It knows everything about itself, and you can get any information back you want from it. So I'll probably do that with like a sprite thing too, which is like an image and a rect together. But right now, this thing that you're looking at here is an image that we've loaded. So what I'm saying is here on this next line is I want a rect. I want a rectangle. And I'm saying I want a rectangle from an image. So I'm saying new rect image. It's a rectangle from an image, and this might be changed. But now I'm using that ID. So this guy right here is going into here. This function is going to check on the C side. It's going to verify that this first is a number. And then it's going to verify that it's actually a number that is possible to be in the images array. It's a correct index number for an image. And then it will use it. And it'll generate a rectangle, and it'll give you back an ID for a rectangle that has put into another array. Now, these arrays that I'm talking about in C, they are resizable arrays. So they start out being like a size 10, and when it gets full, they generate a new larger array, resizable array kind of deal. I just use the same structure for all of it. But anyway, so I have this ID. Now I have an ID to an image and to a rectangle for that image. So if you see down here, and some of this might be simplified later, I'm just messing around with things, but I set render clear, and I want to draw an image. So I say draw image, and I've put the image and the rectangle. I have no source rectangle here. I might actually add the source rectangle. So if you want to change the size, but for the sprite, maybe I don't. I'm not sure, because I kind of want it to be simple, but I also want to leave the ability to do things. And let's see here. Oh, we can also draw rotated. So I was making the snowman flip back and forth. That was actually the same image, but I actually implemented the normal draw and the rotated draw. So this is normal draw image with an image and a rectangle. This one is draw the rotated version of an image. I got the image, saying the image. Here's the image here, the index to the image. Here's the image, the index to its rectangle. Now this 0 right here is the degrees you want to rotate it, and the one after it is the direction. So you can flip the direction like left or right, or you can flip it horizontally, or none, or vertically. So it can be none, horizontal, or vertical, which is just an N, a H, and a V. So if I put an N and an H or a V here, that'll do what it needs to do. But I've held it in a variable here because it's part of my game in Bash. If I go left or right, I need to change that. So you'll see it, or where am I? Sorry, I'm jumping around a lot here, kind of rambling. But where's the game loop? Here's the game loop, while true. And I'm doing this SDL update. This SDL update is going to get the state of the keyboard. So the C server is going to know all keys that have been pressed or have been released or being held down. It's going to know all those keys. Within reason, I didn't map all of them, but like it knows internally all the keys, but you may not be able to get the key. But I don't know, it should be most of them. So it has that state. So like here I'm looking, is the key pressed? So this is the action from going up to down. Has it been pressed? Not being held, but pressed. So, and I want an array back. So I'm saying, hey, I want an array of keys that are pressed down, and then I'm giving all the keys that I want. Escape, F, up, down, space, 1, 2, 3, 4, 5, 6, right? So it's going to give me back now an array. So we already know I populated a global value called array, and I made an associated array up here just for myself. You don't need to do this because this is all the bash side stuff. But I created one. You don't need to do this. You can actually just save that array into another array, but I thought it would be easier for an associated array so I can have a name to it. Again, this is, if you're making your own game in Bash, it doesn't matter. The C code doesn't care about this at all. It's just going to give back an array. It's going to read this line, and it's going to give me back the array with these populated. With zeros or ones, you know, if any of these are pressed, there'll be a 1. If they're not, they're a 0. So it's going to give you an array back. and this will be the 0 index, the 1, the 2, the 3, the 4, the 5, you get it. So right here, I'm just setting this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm setting it to the associated array. So later on, I can say pressed escape. And this is the shortcut to an if statement. I'm saying if this is true, I'm going to say and this, which is if I've pressed escape, I'm going to send the SG quit, and 0 just means nothing bad happened. It's good. Just quit in a good way. If I pressed F, I want to toggle the FPS. So this tells SDL to start spitting out what actual FPS I'm getting so I can see. And these are to change the color. Huh. Okay, let's try that. I forgot I did this because I've been working on a different piece of code. Let me save this. Hopefully I didn't break anything above. So let's press 1, 2, 3. Yeah, okay. Oops, and I broke something. What was it? Oh, I did this on purpose. So where is it? Right here. So the colors, the colors are RGBA. Okay. So you don't have to put the A. The A is optional. So I'm setting it 0, 0, 0, which is going to give me black, right? And 255 is the biggest number that you can give. So that's red, green, and blue. So this is going to be solid red, but it's going to be, the alpha is slightly it's transparent, right? Because 255 would be fully visible, 0 would be invisible, 64 is like pretty invisible, right? So that one works. So that gives you a red that's kind of see-through. This one gives you a white that's solid, although you could, or sorry, a white that's invisible probably. Let's see that again. I'll press 3 and we'll check it out. So 1 was black, yes. 2 was red, that was kind of see-through, yes. 3 should be invisible. Huh, it was not invisible, so maybe I didn't do it right, so that's a bug. Now 4 should crash the game because 4 I'm giving you an invalid number. And it did crash it because 4 right here is 256, and that's not allowed because that's not, it needs to be a uint 8. So I'm testing these numbers. When you input them, my C server says, I need a uint 8. Are you giving me a uint 8, which is 0 to 255? And this one obviously is not. So is this one, this number 5. So let's try number 5 and see if that also crashes. Basically, I'm making sure I'm sanitizing the numbers, and yeah. And it gives you a nice error. It says error, -1. Whoops. -1 is not in bounds from 0 to 255. Error. So first it gives you that error. The second error message is the actual just line. So it's just spitting out the line that, so you know, hey, what was the error happened? Oh, it's on the set text color line. And it's this -1 right here, which is this line right here. And this 0 here that you see, the first 0, this is this. Because this is the 0 index for the text. I only loaded one text, so the first text gets the 0 index. So that will be confusing, but I can't do anything about that because the C server doesn't see this. This is in bash. Whatever number this is being held in bash is what's sent to the C server, and it's a 0 because that's what that was set to. So I'm doing the same thing here with this array, but this one is the held. I want to know, is the ASWD or the left or right being held down? I can't remember what I'm doing now with the ASWD. Oh, I was moving the text around, but I don't think I'm moving it around anymore. Yeah, I kept changing the code, so I'm doing all these different things. Okay, so let's see where I'm creating text. So right up here, I say new text. And when I want a new text object, I need to give it a font. So here's the font. I need to give it a size. This is just a bash variable. It's probably like 50 or something. I can't remember what size, or 100 or it's up here. And that's offset. This is the direction thing. Where's the font size? Text size. Size. Oh, okay, it's right there. It's 50. So that's just 50. That's just in bash. So you need to, when you're making the font for the very first, or the text for the very first time that you want, you need to say new text, and then you need a font, which is in the font folder up here, right here in this font folder. And you need to give a size and then an initial string. And this can be changed. The size can be changed, the string, the color, the movement, where it is on the screen, like all of that can be changed. But this one gives you back an ID to a text object. Now, once you have that text object, you can set a position. And here you can see I'm actually not only setting a position, but I'm setting where the anchor is. Because I'm saying set text position, and this text here that I already have now, this index number, and I'm saying I want the center X and the center Y to be at 400 and 300. So not just X and Y, I want center X and center Y. So now that I have done that, if I set the position again without using these, if I just give it 2 numbers as position, it'll assume that I'm talking about the center X and center Y now. But you can use X and Y, and you can use top, bottom, left, right. Yeah, there's also width and height. You can get back a width and a height from it. Here, I'm setting the FPS, and I just set it to some crazy number because I wanted to see how performant it was. At the time, like I'm making lots of calls to and from C from bash in this tight loop that's happening. How fast is this happening? By default, if you don't set this, it's going to be set to 60. So it's going to try to use 60 FPS, and it's using delta time. So when you tell something to move, you tell it to move by delta time movement. You tell it to move by like 300 would be 300 pixels per second. So if your frame rate is 120 or 10, it's still going to move at the same. It is going to look choppy at the lower frame rate, but it's still going to move the same distance over the same time. So I'll kind of show that real quick. Let's set it to say like 10 or something. Okay, so we can see it's very choppy, but the flakes are falling at the same speed. And I can move back and forth, right? So now I'll put it to what it was before, like 4,000. Oh, let me show the frames per second too. I'll press F, and it's getting 9, 10 frames a second. Now I'll put it to some crazy big number that it can't actually do. So like 7,000. And it's still running the same speed, but it should, hopefully you're seeing it being very smooth. And we'll press F and see what we get, maybe 1,600. So this thing is clocking over at 1,600 FPS. Again, I'm capturing it at 60 FPS, and my screen can only display 120, but I can hear my fan turn on. C doesn't care about that, and Bash doesn't care about that. So it's actually kicking this game over and drawing this stuff and doing all this stuff at 1,700 FPS. So, but normally it would be, like 60 would be the default. If I turn this off and press F here. Okay, so that's if you don't set anything, it defaults to 60. Okay. So I was putting it at big numbers because I want to know performance, because basically the more stuff you put in the game, the slower the performance. So I'm going to show you some tricks that I was like putting in and some of the ways that I was testing things, but I just kind of want to show what's going on with this. So you have ways to set these things. Update just kind of updates. Update also times the game as well. It gets the delta time internally. It doesn't need to tell you back the delta time. It's using it internally because Bash does not use floats. We don't want to use any external commands from Bash. So everything is kind of in ints. But internally, C is going to hold movement and everything else with floats. So you still get your smooth delta time movement, but when you're checking box collision, you don't need those floats. You can just get back but you can also get back floats too. So I believe we'll talk about that in a bit. I'll show you the different things that you can get back. I want to swing back around to that when I'm showing something. So I've shown these kind of things. These are just associated arrays, again, that I just did in Bash here. if you're writing your own game, you can do it however you want. You could literally just put this array into another array and then just use an index number. But it's nice if you see the, can you use there? So if I was holding left, I changed the direction to this direction is either it's about the draw rotated. So I'm saying I want to flip it horizontally, and when I'm going right, I want to flip it none. That means my character is already facing right by default. Hold on a second. Okay, so yeah, that's just showing how I was switching it to left and the right, how I was getting it to flip. All this other stuff is just straight up bash stuff, just doing logic in bash. Update rect. So whenever so you can set, like you could manually move stuff. You don't have to use delta time, but it would be a set. So I could update rect or I could set rect. So say I was wanted something to move, I could just have the X or the Y put it into a variable, and I could just in bash I could set that variable to a different number each turn, each tick of the game, and I could just set the thing to the next time. But if you say update, what update does is you give it an X and a I think I'm just updating X on this one, but you can give it an X and a Y too. Am I just updating? Yeah. So I'm saying for this one, I'm saying I just want to update the X and I want to update it by negative speed. So speed is probably 300. I'm updating it by negative 300 for this rectangle. So I'm taking this rectangle and I'm changing the X, whatever the current X position is in the rectangle, I am moving it by 300 times delta time. So if delta time is a very small number, then I'm moving it a very small amount because I have a very high frame rate. But if delta time is a lower number, then I'm moving it by a lower amount. Say if I'm running at 1/10 of a second, my delta time might be 0.1. So if I take this 300 and multiply it by that, I get 30. So each tick of the game, my guy moves by 30 because my frame rate is only, 10 frames a second or something. But if I was running at 100 frames a second, my delta time would be 0.01. So then I would be moving at 3 pixels per tick of the game. But my frame rate is happening 10 times as fast. I'm still moving the same amount. So you can use update basically, and it internally uses delta time, but you can also just set it and time the things yourself if you want. There's no reason why you can't. I'm just trying to make common sense decisions. Now, if you want to get something, I want to get the left of this rectangle. I could actually set I want to get the X as well. So the left and the X are actually just the same thing. So, but you can say left, right, top, bottom, X, Y. You can also say width and height, either any of those. So, and this is not very efficient because I'm only asking for one thing. This is like a round trip from bash to C, getting an answer back. And the answer is going to be reply. So I'm just checking the reply directly with the offset to see if I've hit the left side of the screen. And I'm doing the same for the right. So I'm just I'm not trying to explain how the whole game works here. I'm just trying to show how you can do different things. But I want to pop over to the text thing because that's where it was more exciting for me. Let's see here. So yeah, lots of different stuff. Basically, you're only sending and receiving. So anything you're sending is like, you can where the thing is or tell the thing to draw. And you can receive back information about it, but then you do all your logic in bash, however that you want to do it. So this is just a for loop based on how many flakes there are. This is just a bash array, nothing to do with C. Let's go over to this other one though. This is more interesting because this is what I was playing around with. So So we'll notice this at the top right here. So again, what's going on here is I have a C server, which is not done. Still a work in progress, but it's here. So all this C code right here is being compiled, but it's actually started in Bash. So I went down a rabbit hole. Let me just see if anybody's asking questions. Sorry, lots of people are asking questions. I've been reading a letter since you dropped it. Oh, okay. Have you been programming in C? So I'm not a professional programmer. So it's somewhere between 0 years and like I've been like playing around with it for like probably 2 or 3. Okay, so let's see here. This is the moment. Same thing with jumping. Yeah. You can use the delta or you can do it however you want. Like that's the idea. But I just kind of want to show this because I went down I went down a whole rabbit hole here. I mean, like this is called nerd sniping. So the initial idea is can you make a SDL game in Bash? And the answer was like no you can't, but sort of, I guess. So the question is how? How could I talk from Bash to C, and how fast can you talk from Bash to C? And let me tell you, you can talk from Bash to C fast. So if you want to know on your system how fast you can talk from Bash to C and back again, there is a little test thing. The code I was just showing you is not on here, but this thing right here, Bash to C IPC, this is a little test program I wrote, which I'll probably need to clean up again. But anyway, it's inter-process communication. I was seeing how fast I could send information to a C server and then turn around and send it back and capture it back. How many times I could do that? Like how long would it take to do it 1 million times? Okay. So yeah. So I went down a little rabbit hole. And so what happened is I ended up with 4 different backends. So I have a C server and I have Bash, but I have 4 different ways to talk from C to Bash. Okay. So if we wanted to kind of see some of these, which one is this? So you notice I said pipe here. When I said pipe, it's using the pipe backend. So this is a Unix named pipe, and this is the winner. So if you were to ask an LLM, let me see if I can do it. Let's just ask an LLM. Let's see, what if I wanted to like have a bash script talk to a C server as fast as possible. Two-way communication. And how would I do that? Let's see what it says. I can tell you right now that it doesn't know how to do this, but it might get close. So we have a socket here, and we have a socket. We have a named pipe. We have TCP socket. So what would the fast? I should have said in Linux. It might think I'm crazy. The fastest method, two-way communication between Bash script and C server, and going fastest. Okay, we got a little table going on here. We got Unix domain socket. We have first in first out named pipe, TCP socket, shared memory, hard to manage safely, very fast. So we got fastest. Unix domain socket. It's not. Slow. Named pipe is slow. Socket is fast. Shared memory is very fast. Signal. Okay, so let's just let for fun, because I already know the answers to this. I went down such a rabbit hole. And also the code that it put above here is BS, nonsense code. Okay. So it's not real. It's not going to work. I could take the time to copy it in, but I can tell you the code is way bigger than that. So what? So who is fast? Shared memory or named pipe or Unix socket? Let me make this bigger. Oh, we got some times and everything. Shared memory fast. Okay, so from bash to C and back. For two-way communication, bash and back, the winner is, was it? Direct memory access. Okay, direct memory. And then let's ask it how. How can I talk using from bash to C? It's going to tell me I need a client, probably. Shared memory, blah, blah, blah. So we got a C server, cool. This ain't going to work, but cool. We got to see, okay, here we go. We got a helper thing. This is what I'm on about. This is also total BS code, not going to happen. Anyway, so it's saying, let me just ask it. So you are saying I call a C helper binary from bash that talks to the server, yeah, and then reply back to the, this is stupid, by the way, this is going to be really dumb, back to the client and bash captures it. I would just make sure if that's what it's saying. Exactly. Okay, so I can tell you right now, the slowest way to communicate from bash to C is with shared memory and a client. It is really slow. Really, 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 really slow. And I can tell you why it's really slow. So what I've done here is I have a client backend, which is that little client program. And then, so like we could keep talking with the LNM and going down a rabbit hole, but it would be, how do you talk from bash to the client and so on and so forth. It would go forever. But anyway, the client backend, and this thing is a small binary that is compiled, with O3 and things like that to be fast. A small binary that sends with a shared memory to the C server, receives back from the shared memory, and then gives that back to the bash. Okay. The next one down here is shared memory directly from bash, which you can do. Instead of having a client, I can just map memory from bash, the same memory that's mapped in my C server, and then talk directly. So that one is also slow, but way faster than the client. The client is really slow. The shared memory directly from bash is faster. A Unix socket, not a TCP socket, but a Unix socket, the simpler one, is also really fast, and the pipe is blazing fast. Okay, so the issue we have here is not talking between two C programs, it's talking from bash to it, right? So I did make that test program, and basically to show you the difference in speed, and you can run it, it's up here. It's here, you can download it and try it out yourself, and you can look at the code and see if you can make it faster or anything like that. But on my system, when the battery wasn't fully charged, I could do 1 million round trips, sending information to C, receiving it in C, sending it back, verifying that it was the correct number. Basically, I'm incrementing a number and then checking to make sure, and So it's got to get 100% of the information back 1 million times, 7 seconds or 8 seconds, I think, when my battery was not fully charged, 7 or 8 seconds with a named pipe. With a socket, Unix socket, it was double that. So it was like 14 to 15 seconds. With a shared memory directly from Bash. So Bash is connecting to shared memory that the C server has also been connected to. And this was a nightmare to set up. It is very complicated. That one took like somewhere between 53 and a minute 6, depending on how, like we're talking about my laptop here is running the Ryzen AI 9 HX370, and we're talking about I'm putting it in quiet mode and low power mode, and also not full battery. So like it's probably it's running at like 10 watts or something like that. So, but it's a pretty fast chip though. So it would do it at around a minute. Okay. So what about the shared memory with the client? The fastest method from the LLM. Okay. 1 million times, 915 seconds, 15 minutes. So we went from 7 seconds to 15 minutes. And there's reasons for this. The big reason is why if you're trying to talk from Bash to C, why are you first talking from Bash to C and then C to another C? Why don't you just talk directly? That's silly. Also, you're using a client and you're spinning up a subshell every single time. And you, besides spinning up a subshell for Bash, which is really slow, you also need to start a binary. It needs to spin up a tiny binary and shut that tiny binary down every time, right? And so that's where it even got. That's where I got. I was like, wouldn't that be slow to like spin up a binary and close it down over and over again, like a million times? And they're like, yeah, it is slow. So why don't you leave it open? Leave it open. And I'm like, if it's already open, how do I talk to it? Well, have another small client binary. It's just like the silliest thing ever. So let me just show you in practice what this looks like. Let's not do this one. So I started playing around with text. So here, text test client, right? Okay. So if this looks really bad on your screen, it looks really bad on my screen. But what this is 200 text objects, all moving around the screen, and they're all checking collision with the edge of the screen. So they bounce off the corners of the screen. This is, I'm going to show you some other optimized stuff. This is the heavily optimized version. Basically, I'm sending back arrays. So I'm trying to cut down on the calls between C and Bash. And let's get the frame rate out of this. I pressed F. It's not very responsive. Okay, so we're getting 5 frames. And again, this is the good version. If I hit 1 right here, we're going to drop down to like 2 frames a second. Do that. If it even accepted it. I don't think it accepted it. Okay, there it goes. That's 2 frames. What if I didn't want to just say hello? What if I wanted a dynamic number that changed every single frame? So I'm going to press 5 here, and it's probably going to crash because something's going to go out of bounds. It didn't get my 5. It's so like 1 frame a second. It's so slow. We need less. Let's put less in there. And I'll fix something that will cause it to crash too. So text, that was here. And I'm doing 200 or 190. So how about just like 19 maybe? And also I want to fix something that basically I want to use the numbers of the X and the Y position for the color. I want to color it. But what happens is if it slightly goes off the screen, then I get an invalid number and it causes it to crash. So what I need to do is, where's the number bit? That's not it. Where am I dealing with the numbers again? With the colors, sorry, colors. So I've done plus 100 here, plus 100. Is it too? So I've tried to use plus 100 here to deal with it. I'm going to say plus like 500. Otherwise, we might get an instance where something was drawn off the screen for a moment, and then when it tries to generate a color from it, it's not going to, because I'm going to use the X and the Y positions to make the color. Well, I'm using the, which one is it? Here, maybe we'll see it. Top, bottom, and left. So what I'm going to do is I'm going to use the right for the number that I'm going to display. And then I'm going to use the top, the bottom, and the left for the color. And they need to be within 255. But the problem is if this number, if it slightly went off the screen because the frame rate is so slow, it will give me an invalid number and crash. So, okay. So we only got 20 of them. Let's try it. Now we're doing the client guy. Okay. So what frame rate we're getting here? Okay, so we're getting 36. This is the optimized one. Let's hit it over to 1. This is the, when I say optimized, what this one's doing right here at 9 frames a second is it's looping over all 20 of these hellos, and each one of them, it's drawing them separately. So it's doing 20 loops for draws. It's going to do 20 loops for getting the bottom and checking the bottoms, 20 loops for getting the side, checking the top, checking the right side. It's looping every single one of them individually. So it's getting one piece of information each time, which is a kind of dumb way to talk between, right? What I made, I instead made arrays so I could say, hey, you know what? Can I just get all the lefts? So I have an array of all the text, which could be like, for this is 20 text. I can say, can I just get 20 lefts and 20 bottoms and 20 tops and 20 rights? So that's like 4 calls to C, and I get an array back of all the answers. And then I can do my math and bash whether any of these have bounced off the wall or not. So this is the slowest method. This is the dumb method where everything is one at a time asking for calls and everything else. This is me. I'm pressing 2 now. And what this is going to do, it's sped up a little bit, is I'm drawing everything at once. So I'm saying, hey, don't loop over 20 and send 20 draw calls to C. Why don't I just tell everything to draw at once? At least all the text. The text already have their own rectangle. So I can just say, hey, send this 20 different index numbers of a text, just draw all of them for me. And so that's what that's doing. When I press 3, it's even faster. This is where I'm basically saying each object, give me the top, bottom, left, and right. So give me an array back of 4 for each object. So I have to call 20 times, but then I can check it. And now when I hit 4, I'm not going to say I'm not going to call 20 times to give me the left, right, top, and bottom each. I'm going to call 1 time and say, give me 20 lefts, 20 tops, 20 bottoms, 20 right. So that's 4 calls. And you see that's much faster because this is very slow. So what happens if I make this dynamic? I'm going to hit 5 and it's going to go to the slowest method of changing the color and changing the text every single frame. Okay, so this is like too slow. You can't make a game like this. This is 6 frames a second. This is terrible. More optimized version where all of them draw at once. Here's the more optimized, and the most optimized is 8. And we're getting 14 frames, and that's just not cutting it. And we only have 20 objects, right? So what if instead of that, I went to the shared memory? This is directly from bash to C server, talking with shared memory. And this is the optimized version for static image. Here is the unoptimized. I clicked over, let me try again to 1, and showing the FPS, 140. And this should be the unoptimized. More optimized, 150, 160, 2 something. And now we're at 500 on the fully optimized. Let's change the text around. Now we have the color and the number changing every frame. This is the unoptimized version, 92. And 5 now, we're at still 90. Oh, sorry. 5 was always the unoptimized. 6 is 100 now. And 7 is 130 about, and 8 is like 170. Okay, so that's 20 objects. That's too little. I really want to see lots of moving objects. So let's add another 9 in here. See what this guy can do. I'm just going to show you the optimized 8. So this is the numbers. Put the F on there. So 18 frames, not good enough. Okay. And I'm also streaming right now. So hopefully I'm streaming. So what if we switched over now from the shared to the socket? Okay. And let's go to the frame rate. And this is the optimized static version. Unoptimized dynamic, we're still getting 24. So not good enough. It's choppy. But what if we do the most optimized? That's number 8 here. Now I'm getting 42. 42, not bad. We're not at 60, but we're better than 30. But this is, realize what I'm doing here. I'm moving 20 objects every frame. I'm checking the top, bottom, left, and right of 200 objects. 200 objects, I'm getting 200 tops, 200 bottoms, 200 lefts, 200 rights. I am drawing all 200 objects. I am changing the text of every one of those 200 objects based on its, I think the right side or something like that. I'm also changing the color of the text. That in C, this is regenerating a text object every single frame for every single one of those things you're seeing. But anyway, let's see what the pipe version is. So this is pipe version. This is the optimized. It starts out on the optimized 4. So let's see the unoptimized text version, and we'll put the frame rate on. So we're getting 33. It's not optimized. This is like the dumb way of coding. And 8 now is the most optimized. And it didn't go up. Did it? Did I press 8? Well, it's not great. It's still 40, so maybe I've done something wrong. Or maybe I'm heating up the CPU. I don't know. But anyway, you kind of see this is like a battle between the socket and the named pipe. It must be something happening. I'm building up heat or something like this because the frame rate's dropping again. So it's probably I'm thermal throttling right now or something like that. But this is kind of like, this is a bit extreme. If you're doing something this extreme, you're probably not programming from Bash. Like if you and I'm not done with everything yet, optimization, but it's like, how fast could you really do things? And so that version of the code, I'm sending things multiple, like 1,000 times. I'm talking to and from Bash in a type loop, like, let's see here. So I'm getting an array of all the keys. That's every loop, getting that associated array answer up. This is changing how I'm changing the modes. I'm checking for toggling FPS or for quitting. So I'm moving all the text first. So this isn't a loop. So there is no shortcut for this one because every single one of my texts has a different X and Y velocity. So what I have here is I have an array of indexes, and I have another array that's the exact same size of the index array for all the text objects. That is the Y velocity and the X velocity. So that's in Bash. That's not happening in C. That's just happening in Bash. Basically, I have 3 arrays. One's got indexes, one's got velocities, X velocities, and Y velocities, and they're the same size. So I'm going through a loop here, and I'm updating it, which is using delta time for each one of the text objects. So that's moving it. And now I need to check, and I have all this code is kind of bloated because I have like 8 different implementations going on here. So it's a little bit hard to understand. Like if it's any of these modes, it's running this code here. What I was doing is let's show you a simple one right here. This is going from the 1 to the 1 to anything that's not 1. So 1 and 5 was the static image to the dynamic image. So those are the non-optimized versions. The most unoptimized version, I am basically going through all the text objects in the array and telling each of them to draw separately. And now if I press 2, 3, 4, or 6, 7, 8, I'm just saying, you know what? Draw the text objects. It's one, I'm sending one thing to C server, which is all of the, you have to use the asterisk here, and it's going to expand to all the indexes. So basically in C, I read draw text, and then I read a whole bunch of numbers. It just keeps reading numbers until it's done or something's invalid. And it goes and draws those things. So that's kind of what's happening here, but it's even more complicated because I'm doing different things in each one of them. I'm doing one like this way. I'm doing each thing separately. I'm grabbing the position. I'm looping through 200 times, and each time of the loop, I'm grabbing the, which one is this? The top position, the bottom position, the left position, the right position. So that's 200 times 4. That's 800, right? And then down here, I'm also doing another. So it's 200 times 6 here, because I'm doing 2 more things here, depending if we're doing the dynamic text. So that it's a lot of sends and receives. So down here, when I do the more optimal version, or where's the 8 version? The 4 and the 8. This one, I am saying I want an array of all the tops, and I just give it the indexes to every text, right? And it's going to give me back an array the size of all the text, but it's going to have all the top as an int. So whatever the y or the top is for every object, now that's in a text T. It's an array of tops, an array of bottoms. So this means that I don't need to send it 200 times. I need to send it 4 times. I'm sending and receiving. It's just done 4 times. Now I can do all my math in bash to do collision checks on the 200, but I'm not sending and receiving from C. So that's pretty good. I still need to, there's no way around it, to set the color in the text 200 times. So this is, happening. This is 400 right here, and this is 4. So this is happening 4 times. This is happening 400 times. And there's other things, So it's kind of like I was trying to put stuff in place to kind of simplify things. Some things you can't simplify, some things you can, like updating movement. There's no way to I'm not going to write it so you can somehow wrap all the movements and the rectangles together. That's too, like, this is just going to be general purpose, but like some things are obvious, If you just got 20 things to draw, just tell them if they can draw themselves, right? If they can move themselves, well, you can't do the move because you need to give, unless they all have different velocities, so you can't really do that. But you can say everything draw, and you can say, I want to check the right side or the bottom side of everything. Just give me all the bottoms back. And you can't say, I want these 15 keys. I want to know if they've been pressed or not. Give me an array back with all of those keys. So that kind of inter-process communication, like I'm trying to speed it up by that way. But like, bash to C can still talk it, like I said, 1,000,000 times with the stripped down code, sending and receiving, getting it back, and verifying the answer in 7 seconds. So that doesn't translate to this game, but that still shows like this isn't so bad. Let's try it again. Maybe the CPU is cooled down. Here we go, and then run the 8 version. Do that. Oh, this is the dynamic. So it's 42 here. Let's just put it on the static hello one and see what we get. 170. That's not bad. The other one, I'm literally changing the color of it and the what is being displayed on it every single frame. So that's heavy lifting, That's regenerating a text that is inside that text object as well too. So there's some stuff happening on the C side of things too. But this isn't bad if if you're just making a 2D, learning how to make some game, some code or whatever, this could be all right. And I'm still wondering if there's some way to dynamically move a bunch of objects. Like if you had a screen background with all the blocks or something, maybe there'll be a one where you're updating everything at the same amount or something like that. But you don't want to get too specialized. Like I just want it to be general thing. But I was just wondering, can you do this? And I guess the answer is yes, but also not that this is not right. That this is not true. It's not correct. It's not right. It's also, it's like, it's not going to work. It doesn't look like that. I'll show you what it does look like. So what I've done here is this C, you compile this C, right? Let me close these. So there is a make file somewhere in here. I guess the make file is here. Yeah, it's right here. So the make file's here. It builds this guy. If you run in the client, you also need the client one too, which is here. But why would you do that? So you get this server here. This is everything that's running the C stuff. And so you have different backends. So I'm going to delete this guy right here. Okay, so we have pipe, shared, socket, and client. So these are kind of the backend. So if we look at any of these things, these two things I showed you here, it's a bash script, and we have this very first thing that is, which one do we want? Do we want pipe, socket, shared, or client? If you don't give one of these, it's going to just close out and tell you to choose one. If you do choose one, it's just going to source it. So what those do is they get the server running and they get communication with the server up and running. So here's the pipe one. So the server is called server SG server, which is this guy right here. And we are going to use some pipe files. For the pipe, I'm using two-way communication. So one pipe is going to C and the other one's coming from C. So to server and from server, and they're just in the temp folder. And I also want to know if I need to shut down the server too. So I want both things to shut down correctly. This one checks to make sure that this file actually exists. If it doesn't exist, it tells you to compile it. It's just to make sure. This creates those two pipes with the make FIFO. So these pipes are actually created in bash. They need to be created before like the C thing is involved. So right here, I am now starting up the server in the pipe mode. And I need the PID from it. So, I need the PID from this script. So it's grabbing the PID from the script that launched it. And I'm putting it in the background. Just to make sure anybody's not asking crazy questions. We're using console to print. Oh, what console? Which one do you mean? The using console to print. Man, I'm not on Discord. I don't have Discord, unfortunately. Let me know what you mean by the console to print. So where was I at? So I'm starting the server up and the pipe mode, and I'm getting the PID of the script that I'm running, and I'm putting it in the background, and this is me. So I have the server has the process ID number of the bash script, but the bash script also has the process ID number of the server. So they could one could shut the other down, basically. So here I'm grabbing the PID of this, but here I'm grabbing the PID of this. So either way, so I make sure the server does get up and running, and I'm opening both pipes. So what's happening here is the server here is probably connecting to the pipes, then I'm connecting. There's always a dance which one needs to happen first. And now I'm creating two functions. This is the shutdown function. So I'm trapping down here. If I get a signal from the server that is a user 1, that means we're shutting down. The server's telling the script to shut down, but it's okay. It's a 0. It's a good shutdown. It's nothing bad happened. If I had an error, I'm giving the signal user 2, which means we're shutting down, but this was a bad shutdown. Okay, and right here, I'm just making sure I'm not trapping exit, so it's not recursive, but I don't think it does it anyway. Here, I'm also trapping if if you're trying to kill it from the command line or something like that, or you're trying to send something else, a signal from somewhere else to shut it down, that it does shut down. So if that was sent from somewhere else, it goes up, runs this function, and it's basically if the server does need to be shut down, if it's 1, I'm going to send the shutdown signal. There might be some times where the server's not running or something like that. I forgot now what it is. There was some reason I needed them to shut down correctly. I am I'm closing the file descriptors for the 2 pipes and removing them. Probably not necessarily, I'm just doing it. And then I'm telling it to be exited depending on which way was passed into this function, either a 0 or 1. And this is the other command here, which is pretty simple. It's basically, I'm echoing this to the server. You can also use printf. I tried both of them. I think echo was just slightly, like 1 second faster in a million or something like that, but speed matters. If it fails, I'm also just telling it to quit. And this is if it's a get or a new, I need a reply. I need that reply back. And read is blocking, so this is very important. You don't want to mess around with this read thing because it blocks. It stops your script from running. So, and the array as well. I'm just saving it as an array. I gave it a different name. So that's the backend for the pipe. For the socket, we're doing mostly the same stuff up here, same stuff, starting in socket mode, same thing, making sure it's up and running. Now we are using this co-process. I don't know that much about sockets, to be 100% honest, of any of this stuff. But anyway, we're opening up these sockets, and I'm using this variable socket in, socket out for the two-way communication. Doing the same thing with the trap down here. It's the same thing with the shutdown. Same thing with removing the sockets. And the server is doing stuff. Remember the C server is doing stuff as well. And here's the implementation. It looks very similar. This one is sending to the socket. This one is receiving for the array or from the reply. And let's see here. The shared one starts to get a little crazy. Let's look at the client one. So this one I have a server and a client. Server is always the same server, but now I have a client one in play. And I have this shared memory. And what I've done here is I'm using one shared memory for data and one for a lock to basically know when you're allowed to send, receive, or read. Okay, so I'm doing the same thing in my client program as well, because the socket and the pipe, both of them they're both blocking. They know when they can read and write and all this stuff. They take care of that for you. With the shared memory, you're literally writing to a piece of memory that another program is reading from too. So they got to know when they're allowed to read and write. So basically, the lock one is I'm just setting one character to 0, 1, 2, or 3, and that's it. And the data can be as long as can be, but the lock one is just you're writing one character to it. And the same thing going on here with the server set. If it needs to shut the server down, I set that automatically to 1 on all of them. Making sure the server is compiled, making sure the client is compiled, and we are touching the 2 files that will be used for the shared memory. And now we have to keep doing this thing where we have to open a file, write to it, and close a file. We always have to close it because it's a shared memory, so it's going to be incrementing along the shared memory. It doesn't come back to the beginning again. There's no way that I know to rewind back to the beginning. So the only way in Bash that you can really do that is to close it and then reopen it. So unfortunately, there's a lot of opening and closing. So I'm opening, and I need to open in read-write mode. If I open it in write mode, it changes the size of the file, and then the C server will crash. So it has to be opened in read-write mode. And then I'm literally writing a character here, but it's just hex. I'm writing a 1 here. And the reason why I'm writing a 1 here initially is to block, is to make sure that nothing gets written or nothing gets read here. Because what 1 means that the message has been sent to the C server. That's what one means. So I don't want the client, which is the bash, I do not want it talking before the C server is up and running. So I'm setting it to 1 initially, and that says it's in the hands of the C server right now. The client will not try to read or write or anything right now, but the C server is not even running. So I'm just initially setting it to 1. That's just to block. And now I'm getting I'm making sure the C server is not already running. So I'm going to shut it down. And now I'm starting it up in shared memory mode and making sure it is running. And the shutdown looks similar. I'm getting rid of those files. And here we have a client running. So the client's doing the heavy lifting. So on this one, I am basically, and I think this is a very slow thing right here. This is trying to be a workaround to not running a subshell, but like you can't. I don't know. It's slow no matter what you do. But basically, if it's get or new, I need something back. So I need to run the client program with whatever the command was that it gave me. So whatever the command that's been sent into here, I'm sending it to the client, which is just a string. And I'm also need something back. So I'm putting that into reply or into array. But if it's not get, new, or array, then I'm just running the client directly. So this spins up the client, sends, maybe it receives, maybe it doesn't, depending on the get, new, or array, and then it shuts down. So that is the slowest method. The slightly faster one is the shared memory directly from bash. And that one is here. A lot of this is the same. I'm setting this lock file to 1, and now we're going to see exactly how this works. I started up in the same shared mode, but I don't have this client thing. It's not even here. I'm using the same server shared mode for the C server. The shutdown looks very similar, and now it's going to change. Now this is where it changes. So this is what's happening kind of on the C client as well, very similar to this. So what I do here is I need to know the status of the lock. And I can only write if the status of the lock is 0. That's the only time the client is allowed to write, is if the lock is 0. So the first thing I need to do is connect up to the lock, read from the lock into status variable, and then I close the lock. Now I check the lock. If the lock is 0, I'm good. If it's not 0, I'm looping. So I'm just sitting here in this loop until it is 0. Once it is 0, now it's my turn to write, basically. So like if I've called this function, it's going to just sit here spinning until it has its turn to write. So once it is 0, that's like my turn to write now. So now I'm gonna connect to data. I'm gonna write to data. I'm gonna close data. Now I'm gonna open lock. I'm gonna set lock to 1 and then close lock. Now I may need an answer back. So if I need an answer back, it's going to be get or new, or maybe array down here, which is going to be the same. If it's not any of those, it's done. It's going to finish out. But if it is one, if I'm getting an answer back, guess what? I need to open the lock again, get the status of the lock, check the lock. Now what happens is if it's 0, I can write. When I'm done writing, I set it to 1. The server is looking at it constantly. When the server sees it set to 1, it says, my turn to read and write. The server reads the information, does whatever it wants to do, now writes information, and then sets the lock to 2. Once the lock is set to 2, the client, which is bash, says, it's 2 now. Now I can connect to the data, read the data, close the data, and once I've got that data, I'm going to now set that lock back to 0. So this is like lots of, back and forth. The array thing is the exact same thing, except I'm reading it as an array with the A instead of the R. And that's basically what's happening in C. I'm very much doing the same thing, but not this with this syntax. And this is faster than the client thing, because the client thing, you're spinning up a client and a subshell. It's very slow. But according to LLM, it's the fast. And I do understand shared memory is fast. But you're talking from bash to C. There's a lot of stuff in between in your way, So basically, these are all different backends. so when you're doing the text or yellow snow, you can chuck this up there. You can just source one of them if you want. You need to source one of these, but you can just chuck this thing up here if you have multiple, and it doesn't care. It's abstracted away from you. It's sending a string. So it doesn't, however you get that string to C, it's one of these four, which is really three with a client app that's also doing the shared. Has anybody got any questions? Probably not. Here, using constant print. Okay. Nope, I don't care about that. Yeah, sorry. Yeah, you got to use Delta time. I'm checking my chat, bro. Sorry, what I need is two laptops here. Another one. That's usually what I do, but I've been struggling just to get this thing up and running. So I'm just happy that it's working right now. But normally I would have another laptop with the chats open on them, so I can just read when somebody has messaged me. Sorry about that. Okay, so so this is all the kind of bash stuff. If you want to see what's happening on the C side, it's kind of broken up into sections too. Basically, this is always a string that's being sent from bash to C, because everything in bash is a string. Pretty much, like whenever you're doing anything in bash, it's a string. Also, it's an int. Let me just show as well that you can. Where is it? Text. So a lot of this is half baked. I haven't got everything done yet, but I was just trying different ways to do things. But if I want something back, let's say I want put this to something reasonable, and let's say I want maybe we'll do the snowman. I'll do it for one of the like the first text or something. So where is the not array get text, just get. So if we did something like this right here, I'm just going to copy this out somewhere. Okay, I'm just going to put a 0 in here. I just want one of the objects. Yeah, and I don't want an array. I just want one of them. But it would still work actually if I put array. It would just give me one answer back. But I'm going to say get. Hopefully that. I'm not 100%. I haven't memorized all the things yet. But let's just echo the answer. Okay, let's see if this works right here. Is this the text one, right? Maybe. So that wasn't correct syntax on the get. It might be the other way around. I'm going to have to change these so that they are like uniform. Can't see. Let's see if this is the correct one, maybe, hopefully. Okay, so you see how we're getting an int back. It's getting the top of whatever the first text is in the array. So we can see it's bouncing around the screen. The number gets smaller, then it gets bigger again. Cool. But so I have it implemented differently for rectangles and text. Again, I'm going to fix all this stuff. But if I did want to float, just in case I really did want to float, the float is available to you. So this should give me a float. Yeah, now I have a float number being printed out down here. See? So the float is available, but again, in bash, you can't use the float. So, it's not needed. Let's see. So we can go top. We could also say bottom or left or right or center X or center Y, something like that. Let's try center Y. That should work. Yeah, we got center Y. We could also say like width or height. That should also work. Yeah, and it's 0, so that's a little bit disturbing. That means I didn't implement it correctly. Maybe I didn't implement it at all. I don't know, but it didn't crash. Yeah, so there's something wrong with my C code. Hold on a second. Okay, so I'm gonna finish it up so we can do some dinner and stuff. So I'm gonna end it here so we can have some dinner and all that. But I'll talk about maybe the C side of it next time and show all the stuff in C. And hopefully I've cleaned up some code and added some more features and everything like that. So yeah. See about where was it? Back to and it's the same. Okay. So thanks for watching. Have a good day, guys. And I'll see you in the next one.